So this question is about binding energy, okay? So we're going to go over binding energy, how to calculate it. So it says, how do we find the binding energy of this nucleus, okay? So I know what the nuclear mass is. So it's the mass of the whole nucleus. Now you need to remember what these two numbers are. So the top number, remember, is my mass number. The mass number is the total number of neutrons and the number of protons inside the nucleus. And the bottom number is the atomic number. That is the number of protons inside my nucleus. Okay, now they give me the nuclear mass in U. Okay, so U stands for atomic mass unit. I want to find binding energy. Now there's two different ways you can do this. One way is you can find the energy by doing mc squared. So you'll find the change in mass. So what we do is find the change in mass in kilograms and multiply by the speed of light squared to find that binding energy. So to find the change in mass, because it was given to me in U, you'd have to go to your sheet and find out what a U is. So on your formula sheet at the front, it tells you that 1 U is equal to 1.661 times 10 to the power of negative 27 kilograms. So that's one way to do it, okay? So then you just find out what is this nuclear mass in kilograms, find the difference in mass between the nucleus and the protons and neutrons that make it up, and then multiply by the speed of light squared. But I think the easier way to do it is that it also tells you in the formula sheet that 1 U is equal to 931.5 mega electron volts, okay? And we know that mega electron volts is just a better way of writing energy, okay? So remember, an electron volt, to get into energy, you just multiply by 1.6 times 10 to the negative 19 to get into joules. Remember, a mega is times 10 to the power of 6. So that's a nice way to do it. So what I can do now is just figure out what is the change in mass. So remember, binding energy is, we know when that nucleus gets formed, the mass of the nucleus is going to be different than the mass of the nucleons that made it up. So I can see that I'm going to have 59 minus 27. That's how many neutrons there are. And you may laugh, but yes, my mental math is that bad. 59, take away 27, but I'm also under pressure because I'm trying to talk and do math at the same time. So it's going to be 32 neutrons, and I have 27 protons. So what I can do then is I look at my formula sheet and think, what is an easy way to do this? So what I can do is I can see what a neutron and what a proton is. So we can see that a neutron is got a mass. Okay, so we got a proton has got a mass, my formula sheet, of 1.00728 U. And a neutron has got a mass on my formula sheet, if I can find it, of 1.00867 U. So you can see how that's going to make my life easier, right? Because I'm going to keep this all in U, find the difference in the mass, and then I know what 1 U is in my energy. So that's what I'm going to do. So what I'm going to do now is my total mass. So I've got 27 of these protons, and I have 32 of these neutrons. So my total mass, I'm going to add that together. So just be slow when you type this in because that's quite tedious to type in. So 1.00728. We're going to multiply by 27 to get our total mass of protons. And now we have to add it to our number of neutrons, which are going to be my 32 times by 1.00867. So the total mass of the nucleons was 59.474 U. Okay, so it's total mass of my nucleons. So you can see the mass of the nucleons is bigger than the mass of the nucleus that makes it up. And that's because when these nucleons get joined together, some energy gets released, right? And that energy that gets released tells us about the binding energy of the nucleus that gets formed, okay? Because remember, binding energy then is how much energy we have to put in to completely split this nucleus up into its individual neutrons and protons. So what I'm going to do now is find the change in mass. So I'm just going to subtract these two numbers. So I'm going to do 59.474, take away 58.93320 to get my change in mass. And my change in mass then is 0.5408 U. Now I know what a U is, so all I'm going to do is multiply that now by 931.5. So you multiply by 931.5 to get what my binding energy is in mega electron volts. And I get 503.7552 mega electron volts.